Welcome to this business case study explainer. Today, we're bypassing the mainstream hype to rigorously deconstruct the hidden economic realities and the absolute scaling bottlenecks of corporate AI implementation. We're looking directly at the raw balance sheet metrics that are literally keeping founders and chief technology officers awake at night.
For the past year, the story we've all been sold is that AI is just going to universally slash corporate costs and streamline our workforces. But the sudden reality hitting the enterprise tech sector is frankly vastly different. Instead of saving money, major companies are getting hit with extreme cloud API bills. Take Uber, for example. They burned through their entire annual AI budget in just 4 months. This supposed efficiency tool has rapidly become a massive unbudgeted capital sink.
A cool $1 million. That's the sheer financial reality of unconstrained workplace usage we're seeing right now at the highest levels. Internal reports show that individual employees at Meta were, at one point, costing the company over $1 million each in pure AI computing overhead. And it's not just the titans either. Your average scaling startups are routinely burning $50,000 a month just to keep these models running.
So, to systematically solve this, today's explainer is broken down into 4 parts. First, the microeconomics of the token. Second, the software optimization architecture. Third, the local infrastructure pivot. And finally, emerging business models.
Let's dive right into Chapter 1, the microeconomics of the token. To really grasp this, we need to establish a quick baseline. A token is basically the atomic processing unit of a large language model. You can think of it as roughly a word, or even just a piece of a word. The catch is, every single prompt, every instruction set, and every response costs tokens. And this dynamic led to a really fascinating and kind of dangerous corporate phenomenon called token maxing. Recently, CEOs began actively incentivizing unconstrained AI usage as a way to measure employee ambition. They even set up leaderboards. They essentially tied performance reviews directly to pure compute expenditure. And here is exactly why that became a massive financial disaster. Just look at this multi-year cost explosion. We've shifted from legacy base layers like GPT 3.5 Turbo, which cost around $1.50 per million output tokens, to modern premium frontier frameworks. You've got Claude Opus 4.8 hitting $50, and GPT 5.5 Pro demanding a staggering $180 per million output tokens. That is an astronomical price hike for everyday corporate tasks. Now, the hardware providers? They see this entirely differently. Chip manufacturers naturally advocate for aggressive token consumption. NVIDIA CEO Jensen Huang actually noted that if a $500,000 engineer isn't consuming $250,000 in tokens, he'd be deeply alarmed. And objectively, that's a completely reasonable ROI if it actually doubles that elite engineer's output. But it becomes highly problematic if a junior employee making $100,000 burns through $100,000 in tokens and only yields a 20% productivity boost. Which brings us to Chapter 2, the software optimization architecture. The good news is we can safely slash this token overhead without tanking our output quality. We just have to apply a really strict 4-step software architecture playbook. Step 1 is the tier shift. This is kind of like setting your default office printer to black and white. It completely prevents employees from instinctively wasting a $180 GPT 5.5 Pro model on a basic internal meeting summary when a free open-weight model like Gemma is perfectly sufficient. You keep the powerful frontier models available, absolutely, but only for active escalation. Step 2 automates that escalation entirely through algorithmic routing. Think of this as an automated triage system middleware. When an employee submits a prompt, the system instantly analyzes the query's complexity and bypasses human discretion entirely. Doing a simple email grammar check, that gets routed automatically to a mini model that's 40 times cheaper. Needed 200-page legal contract analyzed for risk? Boom, that automatically escalates to the pro model. Step 3 is semantic caching, which directly attacks redundant processing. Imagine your HR department. If 10 different employees ask the AI about the exact same 500-page vacation policy handbook, a standard API setup pays to process those 500 pages 10 separate times. Semantic caching deploys memory banks that intercept those repetitive queries and instantly return the previously saved answer. The employee gets an immediate response, and the company completely eliminates that redundant API fee. And step 4 is lean context engineering. You've really got to watch out for the hidden trap of AI memory, because APIs charge for your entire conversation history every single time you hit enter. If you have an hour-long chat, your final prompt pays for the entire hour of previous context all over again. So you have to enforce session pruning, aggressively filter raw data attachments, and convert those long-running prompts into isolated project workspaces. It's exactly like packing light for a weekend trip. You only carry the context you actually need.
Now let's look at the hardware side. In Chapter 3, the local infrastructure pivot.
We're tracking a massive financial migration in the enterprise space right now. Companies are moving away from the cloud API framework, which, let's be honest, is basically booking a variable, token-based Uber ride every time you need a question answered. Instead, they are moving toward owning the car. By investing in local inference hardware, enterprises are trading those highly variable scaling API fees for a fixed, localized electricity overhead on machines they physically own.
Developers are already leading this charge. On the lightweight end, they're leveraging software like LM Studio to run models locally on basic laptops. But on the enterprise scale, we're seeing massive investments into dedicated local machines. For instance, $3,000 Mac Studios are currently facing insane 10-week backlogs globally. Why? Because tech teams aren't using them as standard computers anymore. They're repurposing them as highly efficient, localized inference rigs to completely escape cloud token costs. And this translates to a massive macroeconomic shift. Because huge corporate processing arrays require thousands of these high-end chips, this pivot toward local processing is driving an unprecedented hardware boom. The global AI inference hardware market was recently valued at around $43 billion, but it is now projected to scale to an estimated $410.35 billion by 2035. The very architecture of corporate computing is physically decentralizing. Finally, Chapter 4, Emerging Business Models. So what does this all mean for internal operations? Well, we predict that corporate compensation frameworks are about to radically adapt to incentivize the token-efficient worker. Imagine a software engineer who maintains peak performance but uses routing and caching to slash their $50,000 annual token footprint down to $20,000. Smart enterprises are going to start splitting those operational savings, handing out the difference as massive performance bonuses. Your technical efficiency is literally going to pay out. For the B2B entrepreneurs and technical founders tuning in, this exact architectural bottleneck opens up 3 major high-margin opportunities right now. Number 1, localized inference hardware rentals, essentially leasing out physical rigs to startups who want to dodge API fees. Number 2, specialized token optimization consulting. You literally go into an enterprise and set up their algorithmic routing architecture. And number 3, localized open-source framework deployment agencies, where you fine-tune free models to replace expensive pro models while locking down corporate data privacy. And if you want a historical parallel, just look at the early internet boom. It wasn't just the people making websites who got rich. It created massive fortunes for the folks building content delivery networks, hosting environments, and payment gateways. The infrastructure. The exact same cycle is playing out today. The biggest financial winners of the next decade won't necessarily be the ones building the smartest AI. It's going to be the ones who build the efficiency infrastructure to make AI scalable and affordable for the corporate balance sheet. Which leaves us with the ultimate question. Are you positioned to monetize this architectural bottleneck? Whether you're a CTO desperately looking to cut costs or a founder hunting for a B2B opportunity, the time to act is right now. Go ahead and download our optimization templates from the description below to get a head start. Drop a comment letting us know exactly which technical framework you want us to rigorously evaluate next, and don't forget to subscribe for more objective enterprise case studies. See you next time.